Welcome back to the part 3 of this series. In this video, we are going to add the code to create and list user posts. The link to the repo is in the description. If you want to follow along, check out the tag part 2 or part 3 for the complete code. Then, create a new branch over that commit and you are good to go. Okay, let's go to the GraphQL handler module. And as we are going to be adding more stuff here, it will get a bit crowded. I will have to do a bit of refactoring. We can move the database code for each model into a different file. Let's add a new module, repositories, in the main file. Now, create the repositories folder with a mod file in it. Inside that, let's include the public submodule user and create a submodule file. Inside that, I will create a public struct user repository. I need to have access to the pool from this repository. Let's include an arc of the pool here. Let's import pool and arc. Now we can start implementing the methods for user repository. First, a public function new that will receive the pool arc and will return the instance of the user repository. Then we instantiate that with the pool parameter inside. Next, another public async function that will return all users. We could add pagination here in the future, but for now it will only have a reference to self as a parameter. It will return a result with the vector of users or an app error. Now we can go to the GraphQL module and copy the code of the users function inside the root query. We paste it here and replace the context with self. Now we need to import everything it uses. Client from that pool Postgres. Import the error macro from the slug scope package, and finally the trait from Tokyo PG mapper from Tokyo Postgres row. Next, let's create another public async function to create a user. If we look at the create user function, it will need an input parameter of type create user. So let's copy that. It will return a result with the user or an app error. We can now copy the code of the create user function and paste it here. Now, we need to replace the context with self and import everything we need. Let's add self as a parameter here too. We also need the hashing service. We could instantiate that or have it as a parameter. If we have it as a parameter, it could be an arc of the hashing service. Let's import it and remove the context. Now, let's import the rest of the structs, the error from Tokyo Postgres, SQL state, and app error type. Okay, let's go to the GraphQL handler module. Ideally, I would like to have dependency injection, but we can implement a method in the context that will give us an instance of the user repository, and that's something we can do quickly. A public function user repository. It will receive the reference to self and return the user repository. Inside, from user repository, I call new and pass a clone of the pool. Now, inside the users method of the root query, I can replace the code context.userRepository, then call all and await. And here, instead of the field error, I will return an app error. I can do the same in the create user function. Context, user repository, create, pass the input, and a copy of the hashing service. And finally, await. Let's save and run the server. Try a few queries, and it is working as expected. I can run cargo fix to get rid of the unused imports. I need to pass the allow dirty flag since I didn't commit my changes yet. Good. Now, I want to add one more method to get a single user passing the ID. So, in the user repository, let's create a public async function get with self and ID as a parameter. It will return the user or an app error. Let's copy the code of the method below. And we are repeating a lot of code here. There is room for improvement here, but for now I will keep it like that. Let's update the log context, and in the query we need to add a where clause for the ID equals to the first parameter. Let's import UUID and add the reference to ID in the first parameter. Now, after the collect method, we will have a vector of users as result. Let's try to get the first one using pop. Let's convert the optional to a result, and if there is nothing, I will return an app error. Now, back to the GraphQL handler. In the root query, I can create a new public async function, user, that will receive the ID of the user and the context, and it will return the user or an app error. In here, same as above, context.userRepository.get, pass the ID and await. We save and run the server. Now let's create a query to get the user. Write user, and we need to pass the ID of an existing user as a parameter. So let's comment this for now and execute the getUsers query. I will copy the ID of the user1, uncomment the getUser query, and pass the ID as a parameter. Don't forget to specify the parameter name and the attributes you want back. Let's copy this and ask for all attributes. Now we can run the query, and it worked. Now let's try with an invalid ID. As expected, it checks that it is a valid UUID. Now let's try changing a single letter, and we got an unexpected error has occurred. We need to fix that. Let's go to the user repository and let's write a custom user-facing error here if the result list is empty. User with ID not found. Now let's wrap it in format and pass the ID. The error type will be not found error. Okay, let's save and run the server. Good. Now we have a better error message. There is room for improvement here in the error handling. For instance, if we take advantage of the error type, we could return it as a metadata and have additional information on the error. But let's keep it like this for now. Now let's tackle the posts. We want to do the same as with the user. So let's copy the user repository module and rename it to post, then declare it in the mod file. As I said before, we are repeating a lot of code, but let's keep it like this for now. Now let's replace user with post, change the imports, the post models, and we don't have a create post struct yet, but we do have post. Next, rename post repository, but let's take a look at the user's model module. We need the derive macro for the input object. So let's copy that and paste it in the post module. Create a public struct, create post, and copy the attributes we need to create a post. I will copy the imports from the user. I also need to derive the GraphQL object code for posts. Now, go back to the post repository. Let's continue replacing user. We will reuse the get method. It will return a post and select from the post table. Keep replacing it, and this method is done. We'll do the same thing for the all method. Replace the user with post. Now the create method, create post and return post. In the insert query, we will replace the columns and insert into post. The columns are author ID, slug, title, description and body. There are 5 values as well, so this is okay. The log context should also change to create post. Post don't need a password. So let's also remove the hashing service. We can have this log as an optional value when creating the post. We can generate one if it is not provided. Let's change it in the model to be an option. So let's do a match. If we receive a value, it will be stored as it is. If not, we will generate a new UUID. Now let's fix the parameters. First, it will be the author ID, then slug, title, description and body. Then again, change user with post, the variable name and the error message. Good. Now let's take a look at the error handling. For posts, we need to handle the unique violation error because the slug should be unique, and also that the author exists by checking for a foreign key constraint error. So let's match the error code directly. First, if the code is defined, if it is, match code again. This time, the code C, if C is equal to the unique violation code, we are going to return a similar app error. Let's change the message. Format slug, put the slug here, already exists, and pass the slug as a parameter. Now for the author ID case, the code C, if C is equal to foreign key violation code, and return an app error, but the message will be author with ID doesn't exist, and we pass input.authorID. Since I'm using a nested match here, I also need to add a default case. The borrow checker is complaining about moving input here, so I will just create an author ID variable outside and assign to it input.authorID. post.authorid.clone, and now I can use it. I can see that the nested matcher can be converted into a single match, and maybe there's a better way to move the author here. So if any of you wants to contribute by improving the code, don't hesitate to create a pull request to the repository. We are now done with the post repository, so let's go to the GraphQL handler module. In the context, let's copy this function and replace user with post. Now, in the root query, we want to have the same thing for posts. So let's copy the methods. Change the method names to posts and post repository. Same thing here, post and post repository. Also the response using the post model, and let's import that. The same thing for the mutation. Copy the method, create post, set the create post struct as the input. Let's import it, and the result will be the created post. We'll use the post repository, and we don't need the hashing service here. Cool. Now let's save and run the server. Go to GraphiQL and refresh the page. And if we look at the docs, we can see that the new fields are available, and in mutations, create post is available too. Let's try a query to get post. We ask for the post field and specify all the attributes: ID, author ID, slug, title, description, body, create add, and update add. Now run the query, and it failed to fetch. The error is a panic, so most likely I forgot to change the query in the repository. So back to the code, it's the old function. Let's take a look. And I didn't change the table here, so I will do that. Also update the log context, error message, and variable name. Good. Let's save and try again. And it works. I get an empty list of posts. So let's do a mutation to create a post. I will have a variable input post of type create post. Then inside I will call the field create post, pass as input the input post variable, and I want to return everything. So I will copy all the fields for post. Now on the query variables, I will need to add input post. First, the author ID. I will get the real value later, then the title, description, and body. Let's query the users. I will copy the ID of the first one. We set that as author ID of my mutation. And let's go with title 1, description 1, and body 1. Now let's run the mutation, and a new post was created. If I run the getPost query, I can see it is in the list now. If I change the author ID to something unexistent, I get the author with ID doesn't exist. I can set the slug manually here for title 2. Run it, and it was created. If I try to run it again, I get the slug title 2 already exists message. Great. Now the next thing I want to do is I want to be able to get the post of a specific user as a field. Let's go back to the GraphQL handler. We cannot just add that method in the root query. The field needs to be defined in the user. So ideally, I just need to implement the method in user and define it as a GraphQL object too. The problem is that we already defined user as a GraphQL object in the struct itself, and with this version of Juniper, I cannot use both at the same time. So I will need to remove the derive from the user struct and this GraphQL skip too. And I will need to define the fields again by implementing them as getters. So back to the implementation of user, I will define the getters. This will be a lot more verbose, but hopefully will be easier in the future. So public function ID with a reference to self as a parameter, and that will return an UID, self.id. Public function username with self, it will return a string reference, self.username as a string. The same for the email. Let's copy this to make it quick. We also have the bio and image, but those are optional values, so I can call as the ref to convert it to the type I want. Then I have the timestamps, create add with the naive datetime. Let's import that, also return bio and image. I can return create add as is and do the same for update add. Okay, so with this, we should have the same behavior as before. Now, we want to add the post field here. We will need to create a new public async function, post. It will receive a reference to self and the context, and it will return either the list of posts or an app error. Here we can call context.postRepository and a new method getForUser, pass the ID of the user and call await. Now let's go to the post repository and create a new public async function getForUser, pass a reference to self and the user ID. It will return either the list of posts or an app error. Let's copy the code of the old function and add the where clause. Author ID equal to the first parameter, add the reference to the user ID in the query parameters, and we are done. Let's save and run the server again. Now, back in GraphiQL, let's refresh the page, and in the getUsers query, we can now specify the fields we want for the posts. Let's try with ID, title, and description. And it worked. We now have the posts of each user. Good, but there is a problem. Let's change the log level of the app so we can see it better. Go to the .env file, change the Rust log to debug, and run the server again. Now run the getUsers query again, and let's see what's in the logs. And let's try to understand what is happening. First, we have the prepare statement for the select of all the users. That statement 0 is executed without parameters, and it returned 3 users. After that, we see 3 more select statements to get the posts of a specific user. Those are executed 3 times, once per each user. This issue is known as the N+1 problem, and is a common problem in GraphQL. Let's go to the Juniper repository and check the documentation. Scroll down, and we want the version of the book of the master branch. The section we want is Dataloaders. And as we can see, this is the problem we are having. It says that the common solution is to introduce a data loader with the crate Dataloader-rs. The example here is a bit outdated, so let's take a look at the crate. Rust implementation of Facebook's data loader using async await. We need to include this crate as dependency, also the futures and the async trade package. We need the version for the Tokyo runtime, so let's copy that and go to the cargo.toml file and paste that dependency. We already have the futures library, so I will only need to include the async trait with the latest version. Data loaders have 2 special types that we need to implement, a loader and a batcher. In a nutshell, the loader will get the individual IDs and combine them. That list of values will be passed to the batcher, and I will explain a bit more about this in a minute. Let's start by creating the post batcher. This post batcher will need to have access to the connection pool. So similar to the repository, let's create an arc of the pool. Now we can implement the post matcher. Create a public async function, get post by user IDs. It will receive a reference to self and a list of IDs. We want to do a single query with all those IDs, but still we need to separate the results of each ID. We can do that using a map or a dictionary. So let's have a hash map as a parameter. It will be a mutable reference to a hash map. The key will be the user ID and the value is the list of posts of that user. We are going to load the data into that map, but still we need to handle the errors. So we need to return a result, but in this case will be a unit or an app error. Okay. So let's copy the content of the getForUser method. The difference here is that we now have a list of IDs. Let's first change the metadata of the logs. I'll just use the name of the method. Also import hashmap from the standard library, and instead of the returning post, it will return unit, so we don't need the post variable. Instead of a single ID, we now have the list of IDs as a parameter. So in the query, we want the author ID equals to any of what I pass after the first parameter. This is similar to saying where author ID in this array of IDs. Okay, so once we have the list of posts, we need to populate the map. So let's get an iterator of the list of posts, and then we are going to use fold. Fold is like reduce with an initial value. The initial value will be the hash map, and the accumulator will be a closure that will receive that map and a post from the list. I need to insert this post into the list for that author ID. So first, I need to get the vector from the map To do that, I call entry and pass post.authorID, and in case that the vector is not yet in the map, I can call or insert with and pass a closure that will create a new empty vector of post. Once I have the vector, I can insert a copy of the post and return the map. After that, the batcher needs to implement the batch function trait. It has the same generic as the hash map, the UUID of the author, and the list of posts. To be able to implement this, I need to use the async trait. So let's import that. This macro will allow me to implement the async function of this trait. Then, the first thing I need to do is to define my error type, and in this case, it is app error. Then, I can implement the async function load. It receives a reference to self, then the keys, that is just an array of user IDs, and it will return the hash map we were populating in the previous function. So the key will be the UID, but the value is something weird. Notice that I'm not returning a result here. So how am I supposed to handle errors? This strange signature tells me that I need to return a result per each ID. So the value of the map will be a result of either the list of posts or an app error. It's a weird signature and may change in the future, so make sure to check the Dataloader repository. So let's import this batch function trait. Use Dataloader batch function. Okay, so to implement this, the first thing I want to do is to add a log so I can see if this works. It can be a debug, but I will use info. Load in batch, and I want to print the IDs, so pass the keys as a parameter. Then we need the map. So let's create a variable for it. It should be mutable. Let's call it postmap and assign hashmap new to it. To make it explicit, I will specify the types. After that, we need to call the batch function. I'll create another variable to store the result of it. So call self.getPosts by user IDs, pass the mutable reference of the post map and the array of keys. Then call into to convert it to a vector. Then call await. Let's also specify the type for the result. That is the result of either unit or app error. Okay, once we have that hash map, we need to convert it to the hash map of the signature. And we need to make sure there is always a value in the hash map for each of the keys. The idea here is to iter over the keys, and for each key, create the equivalent result of either the vector of post or the app error. So keys.iter, then call map over each ID, add move to the closure since we need the post map, and I need to get the entry for that ID. Call postmap.entry, pass the current ID. Since ID is a reference, I need to dereference it, so either get the result or return an empty vector. Then I need to convert it to a hash map. I need to return a tuple. The first element will be the key, the copy of the ID, and the second element, the value, the entry result. With this tuple, I should be able to call collect and specify that I want a hash map, but I need to fix the value. It cannot just be the entry. Even if we have a single error, we need to comply with the signature. So let's use result.clone. If we map over this, in case of success, we can replace the unit with the entry. Otherwise, it will be the app error. So call map, ignore the parameter of the closure, and replace it with entry. Good, but I still see an error here. That's because app error doesn't implement clone. Easy to fix. Let's go to the errors module and derive clone for both app error and app error type. One more thing, I need to clone this entry. To clarify, I did all this because of this weird signature, and I need the app error of each element of the hash map. Otherwise, it will be just like this. Anyway, let's continue. Now that we have the batcher, we now need the loader. I will create a new public type, post loader, and let's import from Dataloader cache loader. And the post loader will be the loader with UID as the key, a vector of post as the value, an app error as the error, and the post batcher as the batcher. Then I will create a public function to instantiate a new loader, call it getPostLoader, pass the pool as a parameter, and will return the post loader type. To instantiate, call loader new and pass a new instance of the post batcher with the pool. And the idea is to instantiate this new loader per request. So I cannot just call it in the context as I do with the repository. It needs to be instantiated before that. So let's go to the GraphQL handler module and let's add it to the context. A new public attribute postLoader of type postLoader. Let's import that. Now let's go to the handlers module. And as I said, I need to instantiate a loader per request. So in the GraphQL handler function, create a new variable postLoader and call the function getPostLoader, passing a copy of the pool. Let's import that function and add the postLoader to the context. Cool. Now in the GraphQL handler module, we can finally replace the call in the posts field. Instead of calling the repository, we will call context.postLoader.load, pass the ID of the user, self.id, and call await. Perfect. Now we can save and run the server again. And let's try to run the query again. Now let's look at the logs to see what is happening. The first thing we notice is that loading batch was called 2 times. The first time with a single ID and the second time with 2 IDs. Another thing we notice is that we have only 2 prepare statement calls instead of 4. One for the user select and another one for the post. You may be wondering why batch was called 2 times instead of 1. And the reason is a bit complicated, but in simple words, let's say that the loader is not actually waiting for the user's query to finish. The loader will gather as many IDs as it can, up to a maximum, in one or more ticks of the event loop before calling the batcher load. There is a very good explanation in the original Dataloader repository from Facebook if you want to check it out. I will leave the link in the description. If we want to have more predictable results, we need to have a way to control the execution. If we go to the Dataloader repository, we can see that there is an issue of this exact problem. And one solution they came up with was to increase the number of calls to yield to allow the loader to gather more values before the actual load. But yes, that looks like a hack. But let's try it when we create the loader. Let's set with yield count of 100. Save and run the server again. If we run the query again, I can see in the logs that the batch was called only once with all the IDs. So it worked. And that will be all for this video. If I made a mistake or if there is a better way of doing this, let me know in the comments or send me a pull request to the repository. I will be happy to accept it. If you liked the video, hit the like button. Don't forget to subscribe for future videos. It will encourage me to create more and better content. Thanks for watching.